God versus Nature: The Conflicts Between Religion and Science in History. Chapter 11. Darwin and Evolution: Genesis Under Attack. In the last chapter, we saw how discoveries in geology undermined the literal account of Genesis. By the mid-19th century, it was widely accepted that the story of the creation of the world in 6 days was not literally true, that the world developed significantly over vast periods of time. This made it conceivable that living things, and perhaps man himself, might also have changed. William Paley's Natural Theology. In Chapter 6, we saw how the study of natural theology flourished in England in the 17th century. This interest continued into the 19th century. It acquired a strong new defender in the person of the Reverend William Paley, who published an enormously popular book in 1802 titled Natural Theology, or Evidences of the Existence and Attributes of the Deity, collected from the appearances of nature. The book opens as follows. Quote, "In crossing a heath, suppose I pitched my foot against a stone, and were I asked how the stone came to be there, I might possibly answer that, for anything I knew to the contrary, it had lain there forever. Nor would it perhaps be very easy to show the absurdity of this error. But perhaps I had found a watch upon the ground, and it should be inquired how the watch happened to be in that place. When we come to inspect the watch, we perceive, what we could not discover in the stone, that its several parts are framed and put together for a purpose, e.g., that they are so formed and adjusted as to produce motion, and that motion so regulated as to point out the hour of the day, that, if the several parts had been differently shaped from what they are, of a different size from what they are, or placed after any other manner, or in any other order, none would have answered the use that is now served by it. The inference, we think, is inevitable, that the watch must have had a maker, that there must have existed, at some time and at some place or other, an artificer or artificers." Unquote. Paley makes an argument from analogy, in which the watch is analogous to the living organisms we see around us. This is a form of the argument from design for the existence of God. The argument from design had been presented by numerous earlier thinkers, such as Thomas Aquinas, but Paley gave it a powerfully eloquent statement, designed to appeal to the age of reason, with its respect for our powers of observation and logic. Natural theology contains no mentions of miracles or references to the Bible. Although many thinkers, including the young Charles Darwin, found this argument convincing, the argument from design is not logically valid. Ignorance is not evidence for the supernatural. Ignorance of the natural cause of life is not evidence that there is no natural cause. Ignorance about the natural world is not evidence for some realm beyond the natural world. Nevertheless, this argument was convincing for many 19th century thinkers. The idea that, in principle, a natural explanation may someday be found for the organization of living things was not satisfying to them. Pre-Darwin views of evolution. Before the 19th century, there were only a handful of thinkers who had considered the possibility that current living things had evolved from earlier forms. In ancient Greece, Anaximander speculated that all animals, including man, initially emerged out of the sea. During the 18th century, Enlightenment materialists such as Denis Diderot and Baron d'Holbach proposed that non-living matter, when in the right conditions and combinations, could give rise to living things, even complex ones. They were fascinated by the existence of monstrous births, such as a two-headed calf. Whereas in the Middle Ages, such births had been considered signs from God, Diderot and D'Holbach considered them rare but natural events, which could lead to new species. Another Enlightenment figure who speculated about evolution was the deist Erasmus Darwin, a successful doctor and the grandfather of Charles Darwin. Erasmus Darwin proposed that God had designed living things to be somehow self-improving and to adapt to their environment. He presented his ideas in a chapter of his medical book Zoonomia, or The Laws of Organic Life, 1794. The first theory of evolution to rise above the level of sheer speculation was that of Jean-Baptiste Pierre-Antoine de Monet, Chevalier de Lamarck, 1744 to 1829. As chair of invertebrate studies at the French Museum of Natural History, Lamarck was impressed by the fact that living organisms exist on a continuum of levels of complexity, as well as being adapted to their environments. The geologic column seemed to indicate a sequence from simple to more complex. Lamarck first published his theory in an 1802 paper and then elaborated it in his 1809 treatise, Zoological Philosophy. According to his theory, the simplest living organisms are spontaneously generated out of physical matter when it is acted upon by a material life force or fluid. As historian Eric Larson summarizes, quote, "This force or fluid could transform gelatinous matter into the simplest of animals," he claimed, and gummy matter into the simplest of plants. Once living organisms form, and this happens continuously according to Lamarck, the fluid continues to act on them and their descendants, naturally driving them to evolve into ever more specialized forms. Unquote. Within an organism, Lamarck held that the vital fluid naturally flows toward used organs and away from unused ones, causing the former to develop further and the latter to atrophy. Also, he held, like Erasmus Darwin, that acquired characteristics could be inherited. As a giraffe repeatedly stretches its neck to reach leaves on a tree, the life fluid flows into its neck muscles and causes it to get a little longer. Then this longer neck would somehow be inherited by the giraffe's offspring. Lamarck's theory of evolution encountered immediate and strong opposition from other naturalists. The most strident critic was the accomplished scientist Georges Cuvier, often considered the founder of modern comparative anatomy and paleontology. The French Royal Collection of Animals and Fossils was probably the most extensive such collection in the world, and Cuvier had made good use of it to become the acknowledged master of comparative anatomy. As a result of his studies, Cuvier concluded that none of the species preserved in fossils existed anymore, so they must have died out. He was the first scientist to conclusively establish that many animals had gone extinct. Before Cuvier, most people believed that no species ever died out, and that fossils were not meaningful. Cuvier also concluded that every species is ideally suited for its environment and unchanging, with each of its parts perfectly fitted to the others. Cuvier objected to Lamarck's theory on the grounds that it was wildly speculative with no real evidence behind it. It was not consistent with the many gaps in the fossil record, and there was no evidence for Lamarck's vital fluid or the inheritance of acquired characteristics. But Cuvier's main argument relied on his firm belief that every part of every organism is perfectly and precisely integrated into the organism, so that any small change would make the organism non-viable. This view was not consistent with evolution, unless all of an organism's parts evolved simultaneously. If Cuvier did not believe in evolution, How did he explain the fossil record? Cuvier concluded that there had been a series of catastrophes on the Earth's surface, which had led to mass extinctions. After each of these, there had been repopulations of organisms perfectly suited to these new environments. These were possibly migrations from elsewhere, but some of these must have been new creations. Implicit in Cuvier's theory was a dependence on God for creating new species. But as a student of the Enlightenment, Cuvier never gave scientific arguments based on the Bible. Whereas Lamarck and Cuvier wrote primarily for their fellow naturalists, the author of the next proposed theory of evolution wrote for the general reading public. Scottish writer Robert Chambers anonymously published in 1844 his Vestiges of the Natural History of Creation, and it sold well among the British public. Chambers argued that evolution occurred as part of a divine plan of progress. It began with spontaneous generation on an initially lifeless Earth. Then there was a natural progression from simple living forms all the way to humans, with side branches of the tree leading to other animals and plants. The overall pattern of development was preordained by God. No miracles were required because God had incorporated the necessary laws of creation into the structure of the universe. Unlike Lamarck, Chambers did not specify any mechanism for the adaptation of an organism to its environment. In fact, he barely spoke of adaptation at all. Naturalists heaped scorn on Chambers' book, as he had no real evidence to support his claims. But the book was widely read by the general public, and many started warming to the possibility of evolution. Darwin's discovery of natural selection. As a youth and young man, Charles Darwin, 1809 to 1882, was utterly fascinated with the natural world around him, and he collected and cataloged biological specimens with a dedication unusual for a boy his age. Despite his undeniable passion for biology, Darwin did not immediately choose it as his calling. Following in his father's footsteps, he first studied medicine. Then he turned to theology, but, revealingly, the details of the Anglican faith didn't hold his interest. During all of his studies, however, he had always made time for his true love, natural history. He took university courses on the subject, and his dedication gained him the admiration of a professor of natural history at Cambridge. This professor was instrumental in getting Darwin a position on the survey ship HMS Beagle. The young captain was looking for an educated travel companion of his own age, and Darwin fit the bill perfectly. The ship was to survey numerous locales throughout the southern hemisphere, and the journey was to last several years. When Darwin returned to England almost 5 years later, he had amassed a staggering collection of observations and enough specimens to fill a museum. Quote, "He had left England as a young man fresh out of university with only a good upbringing, a deep-rooted enthusiasm, and amateur knowledge of geology and naturalism to his credit. He was returning with 1,383 pages of geology notes, 368 pages of zoology notes, a catalog of 1,529 species in spirits, and 3,907 labeled skins, bones, and miscellaneous specimens, as well as a live baby tortoise from the Galapagos Islands. His diary amounted to 770 pages, and parts of his journals, sent ahead of him, had already been read by a number of scientists at home." Unquote. Due to Darwin's lifelong dedication as a naturalist, he became intimately familiar with a wide range of natural phenomena, from the most minute concretes to the widest possible abstractions. from such details as the subtle differences in the beaks of various Galapagos finches to the hierarchy of similarities and differences relating all living organisms. His thinking on the question of evolution was grounded not in armchair speculation, but his vast knowledge of all of life's varied manifestations. Darwin was also asking probing and unprecedented questions. If God had designed each creature as a perfect fit for its environment, according to the conventional view, why do identical environments that are geographically separated, such as the Galapagos Islands, support different species? And why do the species of South America, which contain vastly different environments, share essential similarities with each other, which they don't share with their counterparts in Africa and Asia? But the most crucial question Darwin struggled with was that of how evolution occurs. Unsatisfied by his predecessors' vague notions about a divine plan or natural striving, he sought a causal mechanism for evolution that had a discernible basis in observable facts. His answer, the theory of natural selection, was inspired, ironically, by a profoundly flawed treatise on human population growth. Thomas Malthus's Essay on Population, first published in 1798. Malthus maintained that human populations tend to increase geometrically, exponentially, while food and other natural resources only increase arithmetically, linearly. So, argued Malthus, with a population growth outpacing food production, there is a natural tendency for us to reproduce to the point of starvation. Although this argument fails when applied to human beings, whose rational faculty trumps natural population pressures, it stimulated Darwin to consider its relevance for animals. Quote, "The message that Malthus's essay brought home to Darwin is that the majority of all individuals in the natural state do not survive long enough to reproduce. Darwin wondered why some individuals, the minority, should survive and reproduce while others did not. And he saw that the survivors would be the ones best suited to the way of life of that species, best fitted to their ecological niches, in the way that a key fits into a lock, or a piece fits into its place in a jigsaw puzzle." Unquote. Darwin's revolutionary idea was that this process of natural selection would act on naturally occurring variations among individuals of the same species. This would provide a genuine causal mechanism for evolution, and it could, in principle, be tested. Darwin wrote later in his autobiography, quote, "I now had a theory with which to work." Unquote. He resolved to gather more evidence and see if it fit the theory. He decided to study the barnacle, a species whose classification was poorly understood at the time. This developed into a massive undertaking, but it reinforced his confidence in natural selection, because key to his theory was the existence of a large amount of variation among the members of a species. From Darwin's intensive study of barnacles, he concluded that variety was not the exception but the rule. There was no exact body plan governing all members of the same species. Every aspect of every species could be found modified to some extent. As Darwin wrote to a friend, quote, "I have been struck by the variability of every part in some slight degree of every species when the same organ is rigorously compared in many individuals." Unquote. Even a feature as seemingly clear-cut as sex was variable. Barnacles were generally hermaphroditic, with the same organism possessing both male and female sex organs. But there were also species in which male and female were separate organisms that lived attached to each other, or in which several males were attached to a single female. Darwin spent many years patiently working out the details of his theory and gathering more and more evidence to bolster it. He realized that his new ideas constituted an outright assault on the accepted religious view of the origin of species, so he was apprehensive about going public. He shared his ideas on evolution with only his closest friends while he continued to gather evidence. Darwin was, in effect, forced to publish when a young naturalist, Alfred Russel Wallace, discovered the same basic idea independently. Wallace had written a letter to Darwin asking his opinion of the theory. The letter was a complete shock to Darwin, and he was ready to grant Wallace full priority to the discovery. But Darwin's friends helped him coordinate a joint publication, so the theories of both men were first published together as short papers. Darwin's magnum opus, On the Origin of Species by Means of Natural Selection, was published in 1859. It was an instant bestseller. Written for a general audience, it laid out a clear argument, starting with artificial selection. Many people knew that animals and crops had been significantly modified by careful human intervention, by selection of the individuals with the desired traits for breeding. Darwin then proceeded to the idea of natural selection, along with the evidence that it had occurred. Darwin presented the fossil sequence of the geologic column. He also proceeded to give the evidence from biogeography, the geographic distribution of species, and anatomy and embryology. The early embryos of a human and a dog look almost the same. Darwin's theory of natural selection made sense of rudimentary organs, such as the human tailbone, and homologous correspondences in comparative anatomy, such as the five-fingered bone structure of mammalian hands, paddles, and wings. These all made perfect sense as byproducts of natural selection, but not of a mind designing each species to perfectly fit its environment. Although the book did not explicitly say that humans had descended from lower forms, the implication was clear and was made explicit in Darwin's later work, Descent of Man. The question of our origins is particularly revealing of Darwin's extraordinary intellectual honesty. Unlike Wallace, whose belief in our divine creation prevented him from ever accepting our evolutionary origins, Darwin refused to place any consideration higher than the truth. He was willing to follow the facts wherever they led, even if that required him to boldly confront the religious dogmas of his day. And there is no better sign of Darwin's total commitment to reason than the fact that the former student of theology died a non-religious agnostic. The theory of evolution by natural selection is a historic example of scientific induction on a grand scale, a vast integration concerning the nature and development of every living organism. What made it possible was Darwin's lifelong dedication to understanding the natural world, from the smallest to the grandest scales, and his total devotion to truth. The temporary waning of natural selection. Darwin's Origin of Species convinced many of the reality of evolution. However, it was not as effective in converting others to natural selection as the mechanism of evolution. In fact, after an initial swelling of support, there was a decline of interest in natural selection as various critiques were published. The most effective of these critiques came from the science of physics. In the 1860s, the great physicist William Thomson, later Lord Kelvin, calculated the age of the Earth, using the science of thermodynamics, based on the assumption that the Earth was initially a ball of entirely molten rock that had been gradually dissipating its heat into space. His initial estimate was under 100 million years, and as he refined his calculation, his estimates went down. Thomson's calculations did not take into account the radioactivity of the Earth, of which he was not aware. These estimates were generally acknowledged, even by Darwin, as not long enough for natural selection on its own to have created all current living things. Given the fact that Lamarckian evolution, if it occurred, would operate much faster than natural selection, numerous biologists started reconsidering Lamarckian-like theories as alternative or supplemental to natural selection. These included even Darwin himself, who proposed a theory of pangenesis, which hypothesized a mechanical explanation for the inheritance of acquired characteristics. According to this theory, every part of an organism generates tiny gemmules containing hereditary information about itself. Some of these gemmules find their way into the ova and sperm, through which they may be passed to offspring. Other mechanisms for evolution were also proposed. Orthogenesis was the theory that once an organ started evolving in a particular direction due to natural selection, then there was a type of momentum, which caused it to continue evolving even when there was no survival benefit to the continuing changes. The theory of evolution by saltation, also called mutation theory, held that occasionally an organism would give birth to a mutated offspring that would start an entirely new species. While saltation theorists acknowledged that natural selection would kill off clearly harmful mutations, they often did not see natural selection as playing a primary role in directing evolution. There was also a theory of theistic evolution, as seen in the writings of American botanist Asa Gray. Gray agreed with the survival of the fittest aspect of Darwin's theory, but held that God directly causes the variations on which that selection acts. In the 1860s, the Augustinian monk Gregor Mendel had published the results of his hybridization experiments with pea plants, leading to the laws of heredity for binary hereditable traits, which could take one of two forms, such as yellow versus green or round versus wrinkled. Unfortunately, the significance of Mendel's work was not appreciated at this time, since it was not clear how they related to continuous traits, such as the length of a giraffe's neck. At this time, most biologists had a blending view of inheritance, in which they saw an offspring's characteristics as a blended version of its parent's characteristics. Mendel's work was forgotten for decades, until around the year 1900, when it was rediscovered by three different biologists, who then restarted the science of genetics. Ironically, these biologists did not see their work as compatible with Darwin's theory of evolution. Genes seem to control discrete and big differences, not continuous traits. The first large-scale experimental study of genetics was started by Thomas Hunt Morgan at Columbia University in New York in the 1910s. The organism he decided to use was the fruit fly, Drosophila melanogaster. It was inexpensive to feed and maintain, easy to breed in large numbers, and created a new generation every 12 days. Morgan focused on the process by which the accumulation of random, inborn mutations over time can lead to new types of organisms. He saw natural selection as only a process of weeding out harmful mutations, not as leading to adapting an organism for its environment. Like Mendel, Morgan studied discrete traits in which substantial changes seemed to occur suddenly. The Neo-Darwinian Synthesis. The synthesis of genetics with natural selection began in the 1920s with the work of British biochemist J.B.S. Haldane. In a series of highly mathematical papers published in the later 1920s and early 1930s, he argued that Darwin's natural selection combined with Mendelian genetics yields a full mechanism for evolution. Haldane presented mathematical arguments showing that varieties possessing even a slight competitive advantage would eventually come to predominate within a population due to a process similar to compound interest in banking. In 1937, the Russian émigré Theodosius Dobzhansky published his book Genetics in the Origin of Species, which, for the first time, presented the new synthesis for a general audience. By mid-century, the Neo-Darwinian synthesis had become almost universally accepted among biologists. The theory generated a wide variety of predictions that were later verified, such as the existence of specific intermediate fossil forms. This overwhelming explanatory success led to Dobzhansky's conclusion that, quote, nothing in biology makes sense except in the light of evolution, unquote. The rise of evangelical fundamentalism. Religion strikes back. Darwin's theory of evolution prompted a range of different reactions, corresponding to the various ways in which people tried to integrate it with their views about religion. At one end of the spectrum were atheists like Thomas Henry Huxley, who saw Darwin as banishing God from the world. But this view was relatively rare. More popular was the view of those like naturalist Alfred Russel Wallace or geologist Charles Lyell, who accepted the theory's validity for all living organisms except for humans. As they argued, humans are sui generis among the living creatures of the world. We alone have abstract conceptual thought, free will, morality, art, and, crucially, an ineffable spiritual soul. For Wallace and Lyell, at some point during the evolution from primitive primates to modern humans, a supernatural agent must have stepped in to create our unique souls. Thinkers such as writer Robert Chambers held an intermediate position, in which he saw evolution as a fully continuous process, engineered or guided by God, with the end result of creating human beings. The idea of evolution directly contradicted the literal story of the creation of man in Genesis, along with the story of Adam and Eve, and the source of original sin. One reaction among the religious was to retreat and start taking the Bible in a non-literal way, focusing on it more as a source of parables presenting moral ideals. Some Christian sects, such as the Episcopalians and Congregationalists, were more liberal and more open to evolution. In 1885, Congregational pastor Henry Ward Beecher published Evolution and Religion, in which he argued that evolution is the, quote, method of God in the creation of the world, unquote. During the 18th and 19th centuries, there was a gradual increase in the number of scholars studying the Bible and other religious texts in a more secular framework, more as a piece of literature and history than as the revealed Word of God. This was referred to as higher criticism, distinguished from lower criticism, which focused on the exactness of the translations from Hebrew and Greek. French writer Ernest Renan wrote the famous Life of Jesus, Vie de Jésus, which was translated into English in 1863. German theologian David Friedrich Strauss wrote Das Leben Jesu, kritisch bearbeitet, Life of Jesus, critically examined, published in German in 1846 in 3 volumes. Both of these works treated Jesus as a purely historical figure and proposed that the miracles of the Gospels were mythical, and as a result, they generated a storm of controversy. The most widespread reaction to both evolution and higher criticism was to recognize them as attacks on the literal Bible and the foundations of Christianity. In 1874, Princeton theologian Charles Hodge published his book, What is Darwinism? His answer, quote, "It is atheism and utterly inconsistent with the Scriptures," unquote. Genesis clearly describes a world in which God created man in the perfect Garden of Eden, and in which man sinned against God and thereby was condemned by him to a life of toil and pain. The evolutionary view, in contrast, held that humans had gradually risen from savage beginnings to their current civilized state. In the United States between 1900 and 1920, government-controlled secondary-level education quickly became widespread. In areas that had previously been extremely isolated, large numbers of people suddenly learned about modern science for the first time. In their science classes, students studied Darwin's theory of evolution and came home and told their parents that they were descended from apes. Their parents were not happy to hear this. In the 1910s, a group of American evangelicals began calling themselves fundamentalists. They committed themselves to what they saw as the fundamental tenets of Christianity: the inerrancy of Scripture, the veracity of Old and New Testament miracles, and the trustworthiness of end-time prophecies. Baptist Reverend A.C. Dixon edited a series of tracts called The Fundamentals between 1910 and 1915, which expounded these tenets. In the 1920s, America's preeminent evangelist was Billy Sunday. His sermons professed the following ideas: man's inherent sinfulness, redemption through personal faith in Jesus, the Bible is God's literal word. He attacked the scholarship of the evolutionists and those of higher criticism. Quote, "When the Word of God says one thing and scholarship says another, scholarship can go to hell," unquote. Sunday, in his sermons, helped to inspire America's first law against teaching evolution in Tennessee, which was passed in 1925. In 1923, George McCready Price published The New Geology, which attacked geology as the weakest point in evolution theory. He pointed out examples of the violations of the law of stratigraphy and asserted his own law as a replacement, the law of conformable stratigraphical sequence. Quote, "Any kind of fossiliferous rock may occur conformably on any other kind of fossiliferous rock, old or young," unquote. Price argued that the biblical deluge could have created the entire geologic column, and some natural sorting process must have placed the organisms in the current layers. The Scopes Monkey Trial. After the passage of the Tennessee law against teaching evolution in 1925, the American Civil Liberties Union publicly offered to defend any Tennessee teacher willing to challenge the new law. A young science teacher named John Scopes promptly accepted the offer. The trial quickly became a major publicity event, and both sides obtained famous lawyers. The prosecution was led by William Jennings Bryan, a populist politician from Nebraska, a senator and three-time presidential candidate, who was known as the Great Commoner. Leading the defense team was the legendary criminal defense lawyer Clarence Darrow, who had in recent years spoken out against religious restrictions on personal freedom. The prosecution called students and school officials to the stand to testify that Scopes had indeed taught evolution. The defense did not contest this testimony. The defense then tried to present testimony from a dozen evolutionary scientists and liberal theologians, all who would defend evolution as sound science. After the prosecution objected to this testimony, saying that it was irrelevant as to whether Scopes broke the law, the judge eventually sided with the prosecution. At this point, the trial had not directly addressed the supposed conflict between evolutionary science and the Bible. Darrow finally called Bryan to the stand. Quote, Darrow posed the well-worn questions of the village skeptic. Did Jonah live inside a whale for 3 days? How could Joshua lengthen the day while making the sun rather than the earth stand still? Where did Cain get his wife? Best of all, for Darrow, no good answers existed. Bryan could either affirm his belief in seemingly irrational biblical accounts and thus expose that his opposition to teaching about evolution rested on narrow religious grounds, or concede that the Bible required interpretation. He tried both tacts at various times without appreciable success. Unquote. Overall, the result of the trial was a draw. Scopes was convicted and sentenced to pay a $100 fine, later overturned on a technicality. Tennessee kept its law, but the media made the most of Bryan's statements in order to mock the backwardness of the biblical literalists. The trial served as the subject for the 1955 play and 1960 movie Inherit the Wind. The Tennessee law stayed on the books for the next 4 decades. After the trial, Mississippi and Arkansas both passed similar laws, and other states passed lesser restrictions. For the next 3 decades, many school districts and textbook publishers opted to avoid the issue by quietly dropping the subject of evolution from the classroom. Creationism strikes back again. By the 1960s, evolution by natural selection had been established as the fundamental integrating principle of biology, and a series of new biology textbooks featuring evolution in a central role were introduced to the public schools. Over half of U.S. public high schools started using these textbooks. In 1968, the U.S. Supreme Court struck down the monkey laws that prohibited the teaching of evolution in public schools. With evolution re-entering public schools, many fundamentalists looked for intellectual ammunition, and they turned to a recent book titled The Genesis Flood by John Whitcomb and Henry Morris. Published in 1961, The Genesis Flood placed what it called creation science on an equal footing with evolution science as 2 competing scientific views. It promoted the view known as flood geology, which held that all the fossils came from the biblical deluge. This was largely a rewrite of George McCready Price's book, The New Geology, using more recent scientific examples. Organizations were founded to promote this new study. One key organization was the Institute for Creation Research in San Diego. As Henry Morris, the Institute's director, made clear, their priority was not on genuine science. Quote, "The only way we can determine the true age of the earth is for God to tell us what it is. And since He has told us very plainly in the Holy Scriptures that it is several thousand years in age, and no more, that ought to settle all basic questions of terrestrial chronology." Unquote. In order to get creationism into the public schools, its supporters needed to drop the explicit references to the Bible and to start referring to creation science as a competing theory to evolution science. In 1981, Arkansas and Louisiana passed balanced treatment laws for public schools, requiring the teaching of evolution science to be balanced with equal time for creation science. Both laws were challenged almost immediately. In 1982, a federal court in Arkansas ruled the balanced treatment law unconstitutional, violating the Establishment Clause of the First Amendment, holding that creation science is religion and as such cannot be taught in public schools. The Louisiana case was appealed up to the U.S. Supreme Court, which in 1987 ruled that the Louisiana law was unconstitutional, violating the Establishment Clause, because its advocates had explicitly religious motives. The court focused on the intent of the Louisiana law. Unlike the Arkansas ruling, this ruling left open the issue of whether the teaching of creationism as such was religious. They implicitly left open the possibility that there might be scientific evidence for creationism. This left a legal loophole for the creationists. They just had to disguise their motives better to get creationism into the public schools. Intelligent design, creationism in camouflage. By the mid-1990s, scientific creationism had adapted and emerged in a new form called intelligent design, or ID. The advocates of this new view, unlike those of creation science, granted the possible validity of the geological findings of an ancient Earth. But, like the earlier creationists, they set out to advance a theistic worldview in the schools and universities. In the mid-1980s, several Protestant scientists wrote books arguing that entirely natural causes could not account for the origins of life, and that this fact was indisputable evidence for a godlike being. Their books, being somewhat technical in content, did not reach a broad audience. Then, in the 1990s, law professor Philip Johnson described a strategy for regaining the upper hand for religion against advocates of evolution. He called this strategy the wedge. And the first step he advocated was to attack the, quote, ideology of scientific materialism, unquote. This strategy was on full view in his 1991 book, Darwin on Trial, which criticized the naturalistic bias of science, a bias that unnecessarily limited the range of possible explanations and excluded supernatural factors. The first popular presentation of intelligent design from a scientist was a 1996 book by microbiologist Michael Behe titled Darwin's Black Box: The Biochemical Challenge to Evolution. Behe argues that science is unfairly biased against non-natural explanations, and that it should be open to such explanations when entirely natural ones cannot be found. Behe presents an idea he calls irreducible complexity. One of Behe's favorite examples of an irreducibly complex system is the basic household mousetrap, which consists of 5 components: platform, spring, hammer, holding bar, and catch. If any of these components is missing, it is not the case that the mousetrap will catch mice less well. It will not catch mice at all. For an irreducibly complex system to function at all, it needs a complete set of components, and it requires a conscious designer to put them together. Behe argues that numerous biological systems are irreducibly complex. His favorite example is the bacterial flagellum, which resembles an outboard motor. It has a complex assembly of parts that cause a rotating shaft to propel the bacterium forward. Behe correctly observes that if you take away any of its components, the shaft will not turn at all. Evolution can only design systems by relatively small increments, in which each stage has an increased survival value for the organism. So all of these parts must have come into being at the same time, which seems highly improbable. So, Behe argues that it must have been designed by an intelligent agent. According to the theory of evolution by natural selection, each step of adding a component should add something to the survival value of the system. But, argues Behe, this is not the case. A major flaw in Behe's argument is the assumption that, as a biological organ incrementally evolves, it always keeps performing the same function. But when a component is added, or when a small change is made, sometimes the system starts performing an entirely different function. In fact, the bacterial flagellum closely resembles the simpler structure of the syringe used by the Yersinia pestis bacteria to inject other cells. The syringe structure lacks several of the components of the flagellum structure, so it doesn't rotate at all. However, it works perfectly well at injecting host cells. A similar type of argument to Behe's is offered by mathematician William Dembski, who proposes a statistical explanatory filter, by which he claims that he can differentiate between necessity, chance, and design. He argues that if an event's likelihood of being naturally caused is improbable enough, then it must have a supernatural cause. At bottom, the intelligent design movement is just the same old argument from design advocated by Reverend William Paley, repackaged using modern terminology with examples from molecular biology. Intelligent design explicitly attacks the metaphysical naturalism at the base of science. But scientific evidence cannot lead to the supernatural. The idea of the supernatural is a contradiction and an absurdity. Supernatural means above or beyond nature, and nature is everything that exists in the universe, as viewed from a certain perspective. Nature is existence regarded as a lawful realm of cause and effect. Intelligent design on trial. A critical test for the teaching of intelligent design in public schools came in 2005 in Dover, Pennsylvania. In order to make students aware of alternatives to evolution, the Dover Area School District Board provided a statement which ninth grade biology teachers were required to read to their classes. Quote, "The Pennsylvania academic standards require students to learn about Darwin's theory of evolution and to eventually take a standardized test of which evolution is a part. Because Darwin's theory is a theory, it is still being tested as new evidence is discovered. The theory is not a fact. Gaps in the theory exist for which there is no evidence. A theory is defined as a well-tested explanation that unifies a broad range of observations. Intelligent design is an explanation of the origin of life that differs from Darwin's view. The reference book Of Pandas and People is available for students to see if they would like to explore this view in an effort to gain an understanding of what intelligent design actually involves. As is true with any theory, students are encouraged to keep an open mind." Unquote. 60 copies of Pandas and People were donated to the school library by one of the board members, using funds raised from his church congregation. Of Pandas and People, The Central Question of Biological Origins was initially published in 1989 by Dean Kenyon and Percival Davis. It was intended to supplement high school biology textbooks. Of Pandas and People defines intelligent design as a frame of reference that, quote, "locates the origin of new organisms in an immaterial cause, in a blueprint, a plan, a pattern devised by an intelligent agent," unquote. The book discusses 6 separate puzzling issues in biology, such as the origin of life on Earth. For each topic, the book presents the Darwinian explanation and contrasts it to the intelligent design explanation, which it argues is superior. The biology teachers in the district all refused to read the official statement, so an administrator came into their classes to read it in their stead. 11 parents appealed to the ACLU, which got them a team of lawyers for their civil suit against the school board. The resulting trial began in Harrisburg, Pennsylvania in September 2005. The case, like the earlier creation science trials, hinged on whether the teaching of intelligent design theory, as shown in Of Pandas and People, was an example of the teaching of religion, and so violated the First Amendment. The judge was the conservative John E. Jones III, who had been appointed by President Bush in 2002, so members of the board were cautiously optimistic about the outcome. However, at the end of the 6-week trial, Judge Jones' final verdict was severely critical of the Dover School Board, describing its actions as breathtaking inanity. He ruled that intelligent design failed, quote, to meet the essential ground rules that limit science to testable natural explanations, unquote, and that therefore it was, quote, not science, unquote. Jones concluded that, quote, it is unconstitutional to teach intelligent design as an alternative to evolution in a public school science classroom, unquote. This ruling applied only to the Middle District of Pennsylvania, but its influence extended nationwide. In this chapter, and the previous one, we have seen how science destroyed any literal interpretation of the book of Genesis and the origin of man. With the story of Adam and Eve and the fall of man seen now as a mere fable, the validity of the entire Bible was severely undermined. Darwin's entirely natural theory of evolution pulled the rug out from under the argument from design, by showing how the complexity of living things can arise from a completely natural process. A book is a product of a conscious mind. Elevating a book above the evidence of one's own observations and reasoning is the elevation of consciousness over existence. The primacy of the Bible is the primacy of consciousness. The advance of Darwin's theory of evolution involved a severe downgrade of the biblical view of man's origin, based on fully validated observation-based theory. The acceptance of Darwinism and later Neo-Darwinism asserted the primacy of existence.